Did I?
You did.
Did I do every other?
25 to 43 every other.
Okay. Okay, let's see what happened with this problem. Okay. So it's already factored, so you're going to set them both equal to 0. Right. Since it's already factored, you can set this guy equal to 0.
So I'm just dumb. Okay, got it.
But no, this is good to talk about because we do need to talk about this.
Other things to the other side instead of equal to each other, and then I was like, wow, that doesn't get you anywhere.
But the first one, when you get tangent squared by itself, come on, Sam, and you square root both sides.
I think I was just getting dumb. Alright,
cool. You guys don't know how to do that.
How to do what?
This right as of right here, like tangent, like you can get up to there, get tangent by itself, and square root both sides, plus or minus. Don't forget plus or minus. But
They give you no solutions for that one.
no, it's not no solution. Who's? It's Steven. I was like, that is not Colin's voice. Who was that? I didn't see Steven. Oh, good morning. I know. I was like, that's not Colin's voice. It's possible. There is a solution. Okay, so tangent can be bigger than 1. Secant, cosecant, those all can be bigger than 1. Just sine and cosine. But since this isn't a famous guy for tangent on the unit circle, the only way you can find it is with trig inverses, which is the topic that I'm teaching you, but you don't need to know for the final. So that's why this guy you guys can't technically finish. So this is technically how it would work. It would be tangent, inverse tangent of 2 equals theta, and then negative 2. So 2 of those answers. You don't know how to do that one, so don't worry.
okay, so Zach, if we were to have learned it that way, right, because we have 2 answers, you can use inverse. Is that why?
Oh, you have 2 answers because of the plus or minus. The reason you have to do the inverse is because tangent of theta equals 2 is not famous. And since it's not famous, normally we would draw like the triangles and stuff, but we don't have enough information to figure out where the triangle goes in the quadrant. So we can't draw the triangle, so you would just use your inverse trig function.
Okay.
But I didn't teach you guys that, so oops.
But one of the things that got cut out.
Yeah, that's the video I'm going to make, and you guys can watch it whenever you want before calculus so you understand inverses. But this one you can do. 2 cosine of theta plus 1 equals 0. So get the cosine of theta by itself. Negative 1/2, right? And then where is cosine of theta negative 1/2?
2 pi over 3 and 4 pi over 3.
Yeah, I drew the wrong ones. Good job. Those two. So cosine is negative in 2 and 3. So 2 pi over 3 and 4 pi over 3. And, oh wait, that's not 2 pi over 3. Stop it right now. Stop it, Sam. I didn't have coffee today. Oh my god. I desperately need it, sweet Jesus. So those 2 spots are where cosine is negative 1/2. And does it just say primary solutions?
I think so.
Or does it say 0 to 2 pi? It could say primary in the directions, or it could give this.
Did you say 4 pi over 4?
Yeah, shush.
Yeah, just making sure.
That means primary if it says that in the directions. If it's not primary, if it's all solutions, that's when you would add the 2 pi k to each.
It just says solve for the given equation.
Okay.
Since in the book, does it give you the answer?
Yeah, it should give you the answer. It'll tell you if it's, in the back.
So it says, it's plus 2 k pi.
Yeah.
Okay.
So then it's all solutions. In my directions on a quiz or whatever, it'll say all or primary. So yeah, so that one you could do half of it. My bad.
Wait,
Is this test the last? This test is the last test before the final.
This is test 3.
Week, dude.
Yeah.
The finals next week.
When is our final?
Next week.
Next week, next Friday.
Next Friday.
Next Friday.
What else you guys got?
7.5, number 9.
What's that guy say?
Cosine 2 theta equals 3 sine of theta minus 1.
Okay. This is the extra thing in those stupid emails I was telling you about that they want me to show you, but it's not going to be tested, but blah 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 blah, whatever. So irritated. So cosine of theta 2 theta, you guys know what that is. That's cosine squared of theta minus sine squared of theta. So you know that double angle formula. Okay? So the reason I'm rewriting it as that double angle formula is because you want all your angles to be the same. Right now there are 2 theta and a theta. The angles aren't the same. So I want to make all the angles just a theta. So I expanded this out to cosine squared of theta minus sine squared of theta, and then now they're all a bunch of thetas. Okay? The other issue you have is there's sines mixed in with cosines. Okay? And we always either try to factor something or try to make everything a bunch of sines or make everything a bunch of cosines. Here's the fact that you guys need to know that they want me to show you, even though it's not going to be on the test or the final. Here it is over here. Okay. There's an identity, just like there's an identity. This is the identity for that. This is the Pythagorean identity. Cosine squared plus sine squared equals 1. That's the Pythagorean identity. That's the circle. Okay. So if you have cosine squared plus sine squared, it equals 1. Okay. From that identity, and then normally I would explain it all, blah blah blah. But from that identity, you can get what cosine squared is and what sine squared is. Okay. All you have to do is just subtract one of them over. So if I subtract over, look at the glare, it's really weird. Ooh, that's bright. If I subtract over cosine squared from both sides, sine squared equals 1 minus cosine squared. So all I did was subtract cosine from both sides. Now if I wanted to do the other one, if I wanted to solve for cosine squared, I would subtract sine squared from both sides. And cosine squared of theta equals 1 minus sine squared of theta. So you have these identities. So you have those identities. If you see the number 1, you could totally replace it with cosine plus sine squared. If you see sine squared, you can replace it with 1 minus cosine squared. And if you see cosine squared, you can replace it with 1 minus sine squared. Okay. So, over here, what do you guys want to replace? Do you want to replace cosine squared, or do you want to replace sine squared? Cosine, so they can all be sines. So this guy is really 1 minus sine squared of theta. And minus sine squared of theta equals 3 sine of theta minus 1. So that's what we did. We replaced it. That's now we can clean this stuff up. Okay. I have 1 minus 2 sine squared theta. You can add the same things. So I added those guys together. There's 2 of them. Okay. And I'm going to get it equal to 0 because you have an exponent. So I'm actually going to move these over to the right because I want my highest degree to be positive. So I have 2 sine squared of theta plus 3 sine of theta minus 2 equals 0. So I minused 1 over and I added this over. You can factor right now, or you can use u sub, whatever you're comfortable with. It's up to you. What do you guys want to do? Just straight up factor or u sub? You use u sub? So u equals sine of theta, u squared equals 2, or I lied, not the 2. You never count the coefficient. Sine squared of theta. You can, it doesn't matter. It's totally preference. You can factor right now if you're comfortable factoring with your sines. If you don't like factoring with the sines or cosines, you can use your u sub. So it's totally up to you. 2u squared plus 3u minus 2 equals 0. And this is everybody's favorite factoring with a coefficient in front. Yes, nice job. Yep, it works. So now you get u equals 1/2 or u equals -2. So now replace your u's with sine of theta. You're always using this guy for u. So sine of theta equals 1/2 or sine of theta equals -2. So if you would have factored, you would have got 2 sine minus 1 sine plus 2. And then you can solve it. So where does sine of theta equal 1/2? And what's the other guy? And then sine of theta equals -2. Good job. Is this prime? Does it say primary or all for these directions?
Pretty sure it's just primary.
So if it doesn't say all, like it doesn't say anything,
Solve for the given equation again. It doesn't say.
then that, so if it's not specific, then you have to find all solutions.
Yeah.
So just like, trying to think of an example. Just like with your quadratics, you find 2 answers, that's technically finding all of your answers. So if it doesn't say just the primary, then it's all.
So we would just have that at the end of it if it says find all?
Yeah, the plus 2 pi k.
Or we would leave it like that?
Yep.
Okay.
Yeah, nothing crazy for those, yep. So yeah, this Pythagorean identity, that's what they want me to show you. Using that. I didn't show you that because we use that a lot in proving identities, and that's what one of the things we had to skip, which I loved. It's my favorite thing to do. So I was like, well, whatever. And then this doesn't come up till 7.5, and they told us not to teach 7.5, so I didn't say anything about this identity. And then they were like, yeah, you should mention it and talk about it. I'm like, why? So there it is. So the ones in your review are these. Like, I think almost all of them probably need this Pythagorean identity. Those were all pulled from final exams, just FYI. But since I didn't talk about it a long time ago, I'm not gonna throw it on a test. Like, I may have thrown it on a test if I taught you guys, even though it's not gonna be on the final. I'm like, this is a harder problem to do. These are cool problems to do. But since I'm just showing you, yeah. I can't test it. I wouldn't do that to you guys. 9 o'clock. No. So
yeah, I was looking for the upload for it. Is it gonna be up later tonight?
I'll put it up after this. I just probably didn't even think to put it up. My life's in shambles. I don't know. What other problems you guys got? What you got, Colin? It's from 7 point number 33 from 7.4. What's the problem? Because I don't have my books.
Cosine squared theta minus 1 equals 0.
Oh, this is a good one. Alright. So, we want to get the cosine by itself. So, I'm going to add, what am I going to do right now? Add 1 and divide by 2. 2 cosine squared theta equals 1 divided by 2. Now this is a good example following that one where you wouldn't want to change this cosine squared theta into 1 minus sine. That is something we do when we have sines and cosines involved. This is just a cosine. You got one trig function, work with it. Okay? So how do you get rid of a square? You square root both sides. So that's why we don't need to change this cosine squared, because we can get it by itself by square rooting both sides. So cosine of theta equals plus or minus the square root of 1/2. So your goal is to get the cosine by itself and make sure this is just a regular angle and regular sines or just a bunch of cosines. I'm going to clean up this root. I really have plus or minus the square root of 1 over the square root of 2. You can give both of them the root because it's division. And you have cosine of theta equals plus or minus 1 over root 2. So if you're looking at that, like, that's not on a unit circle, Sam. Like, where's cosine 1 over square root of 2? That's because it's in a nasty form. But if you rationalize this, multiply the top and bottom by a form of 1 to get rid of that root, then you're going to recognize what it is. That's square root of 2 over 2. So when you rationalize it, root 2 times root 2 is root 4, which is just 2. It gets the root out of there, and it's on top. So now it's famous. So now you have cosine of theta equals positive root 2, or cosine of theta equals negative root 2 over 2. So now you have those two equations to solve because you had two answers from the plus or minus. So this one's always tricky because people don't recognize that that can be rationalized, and it is famous. So where is cosine of theta equal to square root of 2 over 2?
Oh, 4.
Pi over 4 and or
7 pi over 4.
the positive one has 2 and the negative one has 2. So don't forget that.
3 pi over 4?
Yep, 3 pi over 4. And then theta equals, for the negatives, 5 pi over 4. And 7 pi over 4. So again, depending on the directions, these are your primary. Those are 4 answers are your primary. 2 for this guy, 2 for that guy. And if they wanted all solutions, then you would add 2 pi k to everybody.
So my question was, in the book, they only put pi k for the answer.
There's 2 ways you can do it. Don't worry about the different ways the book does it. Or
So should all of these have 2 pi k?
yeah.
Oh, okay.
Yeah.
Alright.
Now, what do the directions say for this one?
Find all solutions of the given equation.
Okay, so yeah, there's different ways they can do it. If you guys just do 2 pi k, you're safe, you're fine.
Okay.
Yep. So these are your primary. These are primary. Because I'm going to upload these, so whoever's not watching this, they don't know what the heck's going on. And then these are all. So that would be your all. Plus 2 pi k plus 2 pi k. What else you guys got? What are one of the ones from the review?
The review, let me check.
I'm looking review material.
Why were there so many find exactly all you want on the review.
For number 1?
Yeah, for number 1, and then you had a bunch of them sprinkled throughout.
Where? Wait, when?
Do you hate us?
Or are you talking about the building the triangle ones?
No. It was like find the exact value.
But that was just all number 1, wasn't it?
It was all number 1
Mm-hmm.
and number 7.
Oh yeah, that's building. Yeah, that's building the triangle.
I was confused by number 13 on the review.
Alright, let's do number 13. You know how long it took me to put this review together to try to find problems that applied and that I didn't already use? Forever. That's why all these are from the old final exams that we haven't seen, and I was like, crap, they need to know facts to do those problems. Number 13. That says find all primary solutions of tangent square root of x equals 2 tangent of x secant of x. Well, that's fun. Okay. So, just to FYI, hopefully nobody did this or was thinking to do it. You cannot divide by tangent of x, because then that gets rid of a tangent, and you're technically dividing by your variable. You should never divide by a variable. So don't do that. Okay? So I'll give you 2 options. You can work with your tangent and your secant, or you can change everything to sine and cosine.
Do it with sine and cosine.
Okay, that's what I would do. Sine squared of x over cosine squared of x equals 2. Now the 2 is on top. Sine of x over cosine of x. And secant is 1 over. Good job. I think about that for a minute. Which is actually just cosine squared. So I'll just clean that up. Sine squared of x over cosine squared of x equals 2 sine of x over cosine squared of x. Cool.
And then can't you just subtract or multiply the cosine of x?
Yep, you can totally clear fractions. I'm just showing it just so people see the work when they look at these. So you get sine squared of x equals 2 sine of x. And again, you still cannot divide by sine. It's divided by your variable. So what are you going to do from here?
Wouldn't you divide by the 2?
You can, but that's just going to make a fraction over here.
Okay.
You have exponents. What do you do with when you have exponents in an equation?
Can't you pull it down? Or
Before that,
square root? Don't you square root?
if you square root it, you're going to have a square root over this thing, and that's just going to be ugly.
Yeah, okay.
So if you have exponents in any equation, whether it's sines or not,
Can't you split it?
not yet.
Wouldn't you want to subtract the 2 sine x over?
There
and
you
equal
go.
it to 0?
Yeah.
Oh,
So get it equal to 0 first. Get it equal to 0 first.
Okay.
So the only time I'm glad Stephen said that. The only time we square root it is if it's just it by itself. There's only one thing there, a square and a number. Like that's it. That's whether it's sine, whether it's just x squared. That's when you square root it. You don't want any other variables involved when you're square rooting and stuff. So now from here, what can we do?
Factor out?
Yep. So now that it's factored, set them both equal to 0.
So 0 would be the only solution for that?
Yep. Yes, let me stop skipping steps. Yes, nice job. 0 minus 2. Where is sine equal to 0 at?
2 pi and 5.
Yep.
Right?
Yep, x equals... But since it's primary, so you start at 0. Wait. So it's 0. So when you start, I'm glad, okay, I think about what you said, Kelsey. When you start, this is angle 0. So x equals 0 is the solution. So remember, that is a 0 degree or a 0 radian angle. So that point, that first coordinate right there, when you start at the unit circle, that's at 0.
Okay.
So that is a solution. When you plug in 0 for sine, you're here, and you get out 0. Then as you walk around the unit circle, you get to pi. You also get 0. So x equals pi is a solution. When you plug in pi into the sine function, you get 0. When you go around 2 pi, one lap does not count 2 pi. So one lap starts at 0, and then it's not included like at the second time, because then you're counting it again. You're counting the same solution twice.
So it'd just be 0 and 5?
Yeah, so you only count each spot once. So this spot got counted when you started, this spot got counted. You don't count this spot twice.
Okay.
So that's for your primary. When you do all, then that's when you would do 2 pi k, and you would keep counting that spot over and over and over and over. It's same with this one. You would count that one over and over and over and over. So you never count that guy twice. If it only wants primary. So for that guy, that one was total, that one's cool. You didn't need the Pythagorean identity that I just taught you for that one. That one you just had to change into sines and cosines. So that would be okay for the test. Or final. Those are yucky. Those are so cool. Oh, oh no, that one's yucky too. You guys want to do 15 from the review? Since that's due today.
I have a quick question, really quick before we move forward. When you were just talking earlier, you mentioned that if we're doing just primaries, it would be 0 and pi. If we were doing all numbers, would 2 pi be included, or would it be that just that 2k pi?
Oh, for that other one.
Yeah, so
yeah,
13.
so when if you were doing all, the 2 pi would be included, because as soon as you added 2 pi to this 0 guy, because that's the same spot, right? K is how many laps you go. So if you go 1 lap, okay, so if you go 1 lap, it's going to hit it. So if k equals 1, you hit it right there at that first lap.
Right,
If k equals 2, then you get 4 pi and blah, 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 blah. So yeah, all of them, that's when it finally hits that a second time.
Okay.
When you get all of them. But since it only wants primary, and it's for all primary guys, when it's asking for primary, it only wants however many spots it takes to get to one time around. So one time around, you got your 2 solutions. Oh, 15. Find all solutions to the equation Oh, so now this one is find all solutions. The other one was find primary. So make sure you read the directions. All solutions to the equation sine of 2x minus sine of x equals 2 cosine squared of x minus cosine of x. Oh, in the interval 0 to 2 pi, I had to read the directions. In the interval 0 to 2 pi. So again, 0 to 2 pi is just one lap around. So it says 0 to 2 pi. And notice 0 is included, that's the starting point. But 2 pi will not be included because it's already been counted. So that's still primary. Alright, so your goal is to get down to the same types of angles, so x, 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 2x, so we're going to have to rewrite this guy as its identity. That's 2 sine of x cosine of x. Alright. And now you have sines and cosines. This is a good one to do. So I'm going to get everything on one side first of all to start with so I can see what I want to mess with. So it doesn't matter. I'm just going to move this over here. So I can see everything I got going on. I got sines, I got cosines, I got cosine sines. So even if I change this to this guy, this cosine squared guy, to 1 minus sine squared of x, I still have cosines and sines mixed in. Like, I still have two different, what are those things called? Functions. Now, I'm not saying that's not the way to go, but I'm going to see if I can do anything else before that. Do you guys see anything else before that? I have something in mind, but I'm waiting for you guys to see it. And I'm hoping that works. Can you group it? You can group it, and let's see where it goes from there. So I'm going to group these two and these two. Alright, so I can factor out from this guy sine of x. And I'm left with 2 cosine of x minus 1. Is that cool? And for this guy, what am I going to factor out from this guy?
Which one?
From your cosine guys.
Is it cosine of x?
Positive or negative?
Negative.
Negative. Because this guy, look, if this 2 is positive here, I want to make this 2 positive here.
Yeah.
So negative cosine of x. So you get positive 2 cosine of x left there. And then if I took out a negative cosine of x here, what's left?
Then it should be negative 1.
Negative 1. Yep. And look at, yay, they match. Okay. So I have, what they have in common is this guy. I'm going to pull that out. 2 cosine of x minus 1 is what they have in common, and I'm left with times sine of x minus cosine of x equals 0. So technically this guy is also fair game for the test or the final because we didn't use the Pythagorean identity here. I did one of these in the part 2 notes, grouping 1. And now set them both equal to 0. 2 cosine of x minus 1 equals 0, or sine of x minus cosine of x equals 0. And solve for each of them. Cosine of x equals 1/2. Where does cosine equal 1/2?
1/2. That would be, what was it? 1/3? Yeah, pi over 3.
And the other positive 1/2?
5 pi over 3?
Yes. And this is primary, so just those two. And then we gotta solve the other one. Sine of x. Go ahead.
This was asking for all solutions, so
It said all solutions, and then the rest of it said from 0 to 2 pi, like the rest of the directions afterwards. So that's just primary. It said all solutions on the interval 0 to 2 pi. I didn't finish reading directions when I was writing it out. But if it was primary for real, or for real all, then the pi plus 2 pi came. And then sine of x minus cosine of x, we gotta solve that guy. So I'm gonna add cosine x to both sides, because that's when sine is equal to cosine. So when is sine equal to cosine? When is x equal to y? So the x equals,
So that is just be at the origin?
that's which angle has the same x and y value. So on the unit circle, which x and y value are the same?
Let's see.
Because cosine is the x and sine is the y. That's what we want. That's the pi over 4, guys. So pi over 4, so that's this guy. That's a terrible pi over 4. Because you get a square root of 2 over 2, common square root of 2, or common square root of 2 over 2. And then which other one are they exactly the same? Because they're not the same in all the quadrants. So they're the same in the first quadrant. Where's the other one that they're the same?
So it would be at the third quadrant.
Yeah, because they're both negative. Which guy is that?
Say that one more time.
Which pi over 4 is that?
Which pi over 4? That would be 7.
It's the 5 guy, because that's 4 pi over 4, the one whole.
Oh, okay. Yeah, okay, now I see.
So that one's a little tricky because you have both, what are those things called? Functions. So setting them equal to each other and figuring out where they're the same is weird. So that one is totally fair game, something like that with grouping, because it doesn't call for that Pythagorean identity. Now these identities you guys do know, so I am allowed to throw those in there. Good. Bad. Oops. Alright. So, then you gotta know where to get all this information. This comes from the unit circle because it's famous. This comes from your triangle you built. We just built theta. That was that piece. This comes from this comes from the triangle, and this comes from unit circle. So you got to know where to go find those pieces at. So what is sine of pi over 3 on the unit circle?
Sine of pi over 3?
Mm-hmm.
Isn't that the square root of 2 over 2?
That's pi over 4. So sine pi over 3, that's the top guy. That's square root of 3 over 2. Okay.
Oh, okay.
And then cosine of theta, you go to your triangle. So I'm going to write it right here, cosine of theta over 5. And then sine of theta, again you go to your triangle. Sine is opposite over hypotenuse, that's -2/5. And then cosine of pi/3, you go to your unit circle, that's 1/2. And then arithmetic. You can multiply those roots because of the same root. That's the square root of 63 over 10 minus, because that's going to turn into a negative, 2 over 10. I would normally simplify, but since you're going to combine this into one, what's this thing called? Fraction, I want to leave the CD. But you can also simplify this guy a little bit. The square root of 63 is the square root of 9 times 7. So that's actually 3 root 7. So you always have to simplify your square roots. So this is 3 root 7 minus 2 all over 10. So in any trig problem, or any, not even trig, any problem, if you can simplify or partially simplify a root, you should. So that guy, building triangles and using those formulas, you just need to know how to build a triangle. Number one, that's what I quizzed you guys on last week. Just learn how to build those triangles. And then the formulas, you just got to know those by heart. Like, that's it. Just know them by heart, what they break down to, and then where to find the pieces at. So that's one application of using those addition formulas and double angle formulas. The other one is the one from Wednesday. That's the one that's a little bit harder. So I'll show you one of those. That's the one you guys have not been quizzed on. They're going to be on your test. Let me go to the review. So like number 5. That one's harder.
Isn't that just multiplying 1/2 times whatever cosine of pi over, or negative pi over 6 is?
So, I'll show you.
Because that's what I did on the...
But you can't, I'll show you.
Okay.
Find cosine of negative pi over 12. The exact value. Okay. So if you want to do, so half of pi over 6 is pi over 12. That's true. Okay. Or even if you do half of negative pi over 6, that is negative pi over 12. That's true. But what are you writing inside of there? So what you're doing is you're rewriting this. So if you're rewriting this negative pi over 12 using this information, what did you rewrite in here?
I rewrote the... So I took the pi of... What should I call it? The next value for negative pi over 6. And then I multiplied by 1/2 to get the answer for it. Assuming that multiplying the cosine of pi over 6 would give me the...
So two things. You can't just multiply. This is an expression. It's not an equation. So if you're just multiplying a number to this, you just change the whole problem. So you can't just multiply to it.
Okay.
So whether you're multiplying on the outside of this cosine or multiplying on the inside of this cosine, unless you're actually finding the value. So did you say cosine of pi over 6 is this and then multiplied by half of that?
Yeah.
Yeah, yeah, you can't do that either. So that is, you did cosine of pi over 6 times 1/2, right? That's what you did. You just totally changed the problem. That is not the same problem.
Okay.
So that's not the same as this. So you can't find this value. This value is what? Square root of 3 over 2 times 1/2. That is what you did. This problem is not the same. those are not equal. Even if, like, just looking at them, they're not equal. So you can't do that.
So would you do something like adding some? Let me try thinking. Like 1/3 with 1/4, using that concept, trying to.
Yeah, trying to use famous angles. So if we just go strictly with adding, subtracting, so this is negative, right? So if I want to rewrite this as 3 pi over 12 minus 4 pi over 12. So I'm trying to get a negative pi over 12. That's my goal. What subtracts or adds or whatever to get negative 1 pi over 12? Well, 3 of them minus 4 of them gives you negative 1 of them. Is that cool?
So would you simplify those two?
And you simplify hoping you have just found famous angles.
Yeah.
So what's 3 pi over 12 simplified to?
Pi over 4.
Pi over 4 minus, what's 4 pi over 12 simplify for?
Pi over 3.
And are those famous?
Yes.
So that's how you want to rewrite this angle inside of there, using famous angles. And to get there, you got to start subtracting some fractions or adding some fractions, or however you want to see it. Trying to get negative pi over 12, and then simplify and hope that you get famous, guys. So now it's turned into a cosine subtraction problem. Now it's turned into I have to use the formula to work this out. So this is the other way you can use the formulas, because now it's an addition and subtraction formula, or subtraction formula. So you got to get this negative pi over 12, adding or subtracting, because those are the formulas we have. We have addition and subtraction formulas. And then when you simplify those fractions, you better hope you get famous ones. So it'll take a little bit of playing with to get simplified to famous guys. So now when we write this out, the cosine formula is cosine of the first times cosine of the second. And this is a subtraction problem. So here's where you need to be careful. A is equal to pi over 4, and B is equal to pi over 3. Not negative pi over 3. This is our subtraction formula. So it's a positive pi over 4 and a positive pi over 3, and we're subtracting them. So just be careful with that. This subtraction formula for cosine changes to addition. And then sine of the first, cosine of the second. Sine of the second, I like. So now you're going to go and find all those from the unit circle. So we got square root of 2 over 2 times cosine of pi over 3 is 1/2, plus square root of 2 over 2 times sine of pi over 3 is square root of 3 over 2. So you have square root of 2 over 4 plus square root of 6 over 4, and then add those together, the numerators, all over 4. So that's the other application of your addition and subtraction formulas, is breaking these guys up into two famous angles. Same thing if you had degrees. If you had 135 degrees, that's 90 plus 45. And then you go from there. The degrees are easier because you're just adding and subtracting whole numbers. These are harder because you're adding and subtracting fractions, and you got to add and subtract fractions right, and you got to simplify fractions right.
Yeah. Oh, it just looked really difficult at first. Like,
yeah, those, like, go back and look at that video for those kind, and then I did stuff in the homework or whatever, but yeah, those ones take a little bit more thinking with the fractions.
I'll do that for sure. I was looking back at it, your video, and then also the one guy's video.
Oh yeah, Russia's.